Chapter 8, Section 8 is on solving radicals. Okay, so today should make a lot of sense, just basically solving algebraic equations, but now we're just getting rid of, in example A, the third root. Okay, so just like anything else, the first thing that I would want to do is get the third root by itself. So first I would divide each side by 5. So that's going to give me the third root of 16w to equal 4. Okay, and then here's the important part. The next thing I have to do is get rid of the third root. Remember, the third root is the same thing as the 1/3 power, okay, which means to get rid of it, I have to raise each side to the third power, okay? So just like a square root and the square cancel, a third root and the third power cancel. So now that completely cancels, so I'm left with 16w equals 64, and then I would finally divide by 16 to get w to equal 4. Okay, so same rules as before, just, raising it to the reciprocal to cancel out the power. Example B, first thing I'd want to do is get rid of my 2/7. So I could either divide by 2/7 on each side, or I could multiply by 7/2. Whatever seems to work better for you is just fine. Watch your negatives. Negative 14 divided by negative 2/7 is a negative 49. Okay, again, if there is not a number here, okay, by the square, or by the house, that's a square. So to undo a square root, I'm going to square each side. So that cancels everything out. So I just get x to equal. Now be careful here. I did draw parentheses. So negative 49 squared is a positive 2,401. Okay, now at this point, I want you to check your answers, okay, to see if you have an extraneous solution. So that box on the top part of your notes is the only part that's kind of new. If I go to plug 2,401 back into my equation, I would have 2/7 times the square root of 2,401. Okay, so type that into your calculator. If you type that into your calculator, get 14. Okay, however, I was supposed to get a negative 14. So that is not equal to what I want it to be. Okay, so this answer is called extraneous. And what extraneous means is when you plug it back in, okay, it doesn't actually work. So we did our math right, but because of this negative right here being squared and it canceling out, it means when we actually plug it back in, it doesn't work. Okay, so back when you were little, you checked all of your answers. It's going to be really important that you check all of your work here. Okay, especially when you've got negatives. That's where you're going to have extraneous answers most of the time. So you tell me the answer is 2,401 and then you label it extraneous. So let's try another one like that. If we look at example C, first thing I would want to do is move the 6 to the other side. So I'll subtract 6. So I'll have negative the 4th root of y to equal 4. At this point, I would want to get rid of my negative. So I divide each side by a negative 1. So I'd have the 4th root of y equals a negative 4. Okay, to get rid of that 4th power, okay, you need to raise each side. I'm sorry, to get rid of the 4th root, I need to raise each side to the 4th. Again, it is a power, okay, it's an exponent. So again, I had negative 4 in parentheses to the 4th is going to give me a positive 256. If I plug that back in, okay, so plug it back in. I'll do that in a different color. So I'm plugging this in. 6 minus the 4th root of 256. That is going to give me a 2. Okay, the original one wanted to give me a 10. That is not equal to 10, which makes my answer extraneous. Okay, now, do you have to show me the work to checking it? Not necessarily, but I think it's helpful to write it out so that you can see whether or not it is extraneous or it is not. Okay, if you're not sure how to do the 4th root here on your calculator, you can just do 256 to the 1/4 because the 4th root and the 1/4 power are the exact same thing. Otherwise, I can show you where that is on your calculator tomorrow. Okay, so let's try example D. We've got a lot going on here. First thing I would do here is I would subtract 67 from each side. That's going to give me the 3rd root of 5z plus 4 to give me 9. Okay, at this point I want to get rid of that 3rd root. So I'm going to raise it each side to the 3rd power. So that 3rd root cancels. So now I'm left with 5z plus 4 to equal 729. So from here I'll subtract 4. 5z equals 725. Divide by 5, z will equal 145. Okay, so again, I'll plug that in. Now I'm going to get 67 plus the 3rd root of 5 times 145 plus 4. Okay, so type that in. your calculator, I would first start with 5 times 145 plus 4, raise that to the 1/3, add 67, and you will get 76. Because that is originally what I wanted, I'll have a smiley face, and my answer is not extraneous. So my answer will just stay z equals 145. Okay, so notice the difference between C and D. In C, okay, 2 did not equal, okay, what I wanted it to equal, so it was extraneous. Here, they did turn out equal, so I do not rate it extraneous. Okay, so take a look at that, and we'll see if the last one is extraneous. We'll see how good we're doing at checking this. Okay, in example E, 25 minus 16 third roots of f plus 1 equals -7. Some of you are going to want to put this part together. Okay, you cannot put that together because of this third root. Okay, that third root is like a label. Okay, it's like a variable. You cannot put them together because the 25 does not have that third root. So what you need to do first is subtract 25 from each side. Again, watch your negatives. I've got a -16 times the third root of f plus 1 to equal -7 minus 25 is a -32. Watching your negatives here. Okay, again, I need to get the third root by itself, so I'm going to divide each side by a -16. So I'm left with the third root of f plus 1, -32 divided by -16 is a +2. Please, please, please watch your negatives. To get rid of a third root, I need to raise each side to the third power. So the third power cancels the third root. That way I'm going to get f plus 1 to equal 2 to the third, which is 8. So f will equal 7. At this point, I need to check to see if that is extraneous. So I'm going to plug it in. So I'll get 25 minus 16 times the third root of 7 plus 1. Okay, so if you're going to do this in your calculator, first thing you're going to do, 7 plus 1, so that gives me 8. Okay, then the third root in your calculator, you might have to do 8 to the 1/3. That's going to give me 2. Now I've got 25 minus 16 times 2. If you type that into your calculator, you're going to get 25 minus 32, which is a -7. Okay, what I wanted to get out was -7, so they're equal, so this answer is not extraneous. Okay, so just be sure you're checking. Okay, again, if you're not sure how to check that or type it in your calculator, just let me know tomorrow when we get to class. Okay, and we've got one last problem, and it's a distance formula problem. So the question says, find the 2 points on the line y equals 5 that are 6 units away from the point 3,1. Okay, so basically you've got the formula above you. So that is going to be your x1 minus your x2 squared plus your y1 minus your y2 squared, and that is your distance. Well, it tells us that our distance is 6, so that whole thing is going to be set equal to 6. Okay, I know that I have 2 points on the line y equals 5. Sorry about that. Oh, my computer's freaking out here. Where did it go? Okay, sorry. Okay, I think we're back in action here. I think my computer is done freaking out. Okay, so I also know that I have the point 3,1. So what I can do is I can plug that in for my x1 and my y1. So instead of x1, I will now have 3. So then I've got 3 minus x. Okay, or I could plug it in for my x2, which will look a little nicer and it doesn't really change anything. So let's go x minus 3 squared, and then I'll have y minus 1 squared to equal 6. Okay, so you can plug that in for your x and your y. I also know that I'm on the line y equals 5. So I can plug 5 in for my y. Okay, so now at this point I've used every piece of information and now I need to be able to solve. So from here, I can rewrite my equation as x minus 3 squared plus, well, now that I know this is 5, 5 minus 1 is 4. 4 squared is 16, so I can change that to a 16, and that equals 6. So once we plug in all that information, it actually turns out to be a pretty nice equation for us to solve. First thing I'd want to do is get rid of my square root. So to get rid of my square root, I would need to square each side. When I square each side, I'm going to be left with x minus 3 squared plus 16. I'm going to pause here. Okay, it does not affect this piece at all. Okay, the only thing it affects is the square root that it was originally under is now gone. So you get exactly what you had before, okay, comes down. Okay, all that we got rid of is the square root. Okay, so then 6 squared is 36. From here, I would subtract 16 from each side. So I would be left with x minus 3 squared equals 20. Okay, at this point, I would probably then square root it. So it seems to be a lot here. And then we're going to get x minus 3. Just make sure you're doing everything here in the right order. And the square root of 20 is 4.47. Okay, now remember when you square root something, and this is a really important idea here, when you square root something, it's got to be a plus or minus. Okay, so now when we go to solve, we're going to add 3 to both of those values. So I'm going to get x could equal 7.47, or, okay, if it was negative 4.47 plus 3, your answer would be negative 1.47. Okay, so now I've done all this work, but I haven't actually answered the question. The question says find the 2 points that on that line that are 6 units away. So now I know the x-coordinates. So my x-coordinates were 7.47, and it said it was on the line y equals 5, so my y value is 5, and then the other one would be negative 1.47, comma 5. So these are the answers to that question. So that one kind of wraps everything we've done up into one. So just take it step by step and hopefully you'll be okay. All right, if not, write down some questions for me. As always, wise people never stop learning. So think about it and come to class with questions tomorrow.